T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
This is Vince Leonard speaking for the National Air and Space Museum at the Smithsonian Institution in Washington. Here are the sounds of space flight, the voices of the pioneers, and highlights of the events documenting man's greatest exploration adventure in history. Man in space. Once a dream coupled with science fiction, now a reality based on fact. The majority of all space technology is a product of the 20th century. It is the result of such great pioneers as Tsiolkovsky, Robert H. Goddard, and Oberth, all who recognized that the liquid propellant rocket was the key to space flight. History records that rockets were in use as early as the 13th century. These primitive rockets harnessed gunpowder for the propellant and were first developed by the Chinese. From these meager beginnings have stemmed the sounds of space we are familiar with today. The catalyst that blended the wisdom of the centuries and that jarred America into making a run for the moon was a 184-pound chunk of metal called Sputnik 1, launched by the Soviet Union on October 4th, 1957. It was the first man-made object to orbit the Earth. Here is the historic sound that electrified the world. A little over 4 months later, on January 31st, 1958, an Army Jupiter C rocket developing 83,000 pounds of thrust carried Explorer 1, America's first successful satellite into Earth orbit. These telemetry signals, supported by more accurate information from Explorer 3, led to the discovery of the Van Allen radiation belt. Vanguard 1, a grapefruit-sized satellite, was launched March 17th of the same year. It was the first U.S. satellite to use solar batteries and made the discovery that the Earth is slightly pear-shaped instead of a perfect sphere, a fact confirmed by later satellites. This is IMP, Interplanetary Monitoring Platform. It was designed by the National Aeronautics and Space Administration and was launched to measure the effects of radiation and solar flares in deep space. This almost musical signal was recorded from Ariel. Launched on April 26, 1962, it was a product of the joint efforts of the United States and England. Mariner 2 was one of a series of space probes designed to find out more about deep space and the planet Venus. It sent back 90 million units of data. The sounds you are now hearing represent the climax of its flyby Venus on December 14th, 1962, 100 days and 180 million miles from Earth. This signal is from Alouette. Developed by Canada and launched by the United States, it represents the first satellite completely fabricated in a country other than the United States or Russia. The sounds of Telstar, the initial step in establishing a worldwide communications network. Developed by American Telephone and Telegraph and launched by NASA, the two Telstar satellites were launched on July 10th, 1962, and May 7th of the following year. The world's first synchronous communications satellite was named SYNCOM. Since its orbiting speed is the same as the Earth's rotational speed, it hovers in one place above the Earth, thereby greatly facilitating the transmission relay of radio, television, and telephone signals. The first voice transmission tests via the SYNCOM communication satellite were on July 31st, 1963.
This is a voice transmission test being rebroadcast by the SYNCOM synchronous communication satellite. The purpose of this test is to evaluate the audio quality of the SYNCOM communication system. The SYNCOM satellite was launched by the United States of America from Cape Canaveral and is a part of this country's effort to develop a worldwide communication system.
September 12th, 1962. The late President John F. Kennedy at Rice University stating our national purposes for space exploration.
In short, we set sail on this new sea because there is new knowledge to be gained and new rights to be won, and they must be won and used for the progress of all people. But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Liftoff and the clock has started.
At 9:34 a.m., May 5th, 1961, astronaut Alan Shepard was launched on a 302-mile suborbital mission down the Atlantic Missile Range. 2 minutes later, his space capsule, which had been launched by a Redstone 3, developing 78,000 pounds of thrust, was traveling 116.5 miles above the Earth's surface at 5,306 miles per hour. Astronaut Shepard describes the view on this historic flight.
On the periscope, what a beautiful view. Cloud cover over Florida, 3 to 4 tenths near the eastern coast. Obscures up through Hatteras. You can see Okeechobee, identify Andros Island, identify the reefs. Start retro sequence, in retro attitude, arc range.
On February 20th, 1962, a Mercury Atlas rocket placed John Glenn in orbit for America's first manned orbital flight.
T-minus 18 seconds and counting engine start.
You have firing signal.
Good Lord, ride all the way.
Godspeed, John Glenn. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Roger, the clock is operating. We're underway.
5 minutes and 4 seconds after liftoff, astronaut Glenn experienced weightlessness for the first time.
Seco. Lots of grades fired. Okay. Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous. Capsule turning around, and I could see the booster during turnaround just a couple of 100 yards behind me. It was beautiful.
Roger, 7. You have a go. At least 7 orbits.
Roger.
During re-entry, friction with the Earth's heavier atmosphere against the heat shield created a huge fireball.
This is Friendship 7. I think the pack just let go. This is Friendship 7, a real fireball outside.
A Titan rocket put Gemini astronauts James A. McDivitt and Edward H. White in orbit on June 3rd, 1965. The Gemini flight series for 2 men was designed to further test man's acceptance of the hostile environment of outer space and to perfect and refine the techniques necessary for the lunar mission. Before their return 4 days later, astronaut White made his famous walk in space 120 miles above the Earth's surface.
Flight director's got to say.
The flight director says get back in.
This is Jim. What, got any message for us?
Jimmy 4, get back in.
Okay. I don't know, we're coming over to the west there. They want you to come back in now.
Roger, we've been trying to talk to you for a while here.
No, back in. Come on.
You can almost not back in, but I'm coming.
We still got 3.5 more days to go, buddy.
I'm coming.
This walk in space was no mere stunt. It was a deliberate and methodical test of techniques future astronauts may have to use in space exploration. Pioneering is never without its price. Astronaut White, along with fellow astronauts Virgil Grissom and Roger Chaffee, was to later lose his life in the 1967 Apollo 1 tragedy. Continuing Gemini flights were to see the world's first successful space rendezvous, the docking of a capsule with an Agena vehicle, and the world's longest orbital mission.
The flight director would like to speak to you for just a moment. Good morning, Gordo.
Yes, how are you?
How does it feel for the United States to be the new record holder?
At last, huh?
Roger. Congratulations.
And the world's longest orbital manned flight of 330 hours, 35 minutes, and 31 seconds. During that 14-day flight of Gemini 7 in December of 1965, astronauts Frank Borman and James A. Lovell, Jr. discussed their spacesuit with ground flight director Chris Kraft.
Frank, we're moving right along in this suit situation.
Roger, there's no question in our minds the only way to fly these things is without pressure suits. I'm convinced we can run the whole works without suits. All we need is a suit for re-entry and emergency stored on board somewhere.
But what about our future in space? And just how significant have our efforts been thus far? Dr. Werner von Braun, America's leading contemporary rocket expert, summarizes the meaning of our efforts.
We have not yet entered the second age of discovery, the exploration of outer space. We are still in the harbor. We are still building and checking out the seaworthiness of our craft. We are still learning the things we need to know about the new medium through which we shall have to travel. The Mercury astronauts were not the explorers. The Mercury astronauts were the test pilots, but they did not leave the harbor of Mother Earth. But we do stand on the threshold of the second age of discovery. When the craft is ready and the oceans of space are calm, because we have learned the new medium and have prepared to sail on it, the new explorers will venture forth. The space age Columbus and Magellan are presently unknown, but they are sitting somewhere today in a public schoolhouse preparing for an adventure that exceeds the wildest daydream which today distracts them from their books.